Hello everyone! Today we're going to show you an example on how to solve problems involving proofs by induction. But before that, we need to define first what is proof by induction. Proof by induction is just like an ordinary proof in which every step must be justified. If you've done proof by induction before, you may have been asked to assume the n-1 case and show the n case, or assume the n case and show the n plus 1 case. Now let's show you an example. And we have this problem. Proof using induction. 1 plus 2 plus 2 squared plus plus 2 to the power of n minus 1 is equal to 2 to the power of n minus 1. But how are we going to solve that? To solve that, we're going to follow these 4 steps. First, show true for n is equals 1. We're doing this step to know if the problem can be really proven or if the problem is really applicable to the situation. Next is assume true for n is equals k, and that is done by the process of mathematical induction assumption, or MIA. The third step is where we are going to show or prove that the given problem is true by using n is equals to k plus 1. Lastly, we're going to restate our final answer. Now, let's take a look at this. What we've done here is that we substitute the value of n with 1 on the last term, the left side of the equation, which is 2 to the power of n minus 1, and on the term on the right side of the equation, which is 2 to the power of n minus 1. The result would be 1 is equals to 1, and that shows that the problem is applicable with the first term. So we can try to move on the next step. The next step is just easy. Since we're just going to assume true for n is equals k, then we're just going to substitute n with k. And the result would be 1 plus 2 plus 2 squared plus plus 2 to the power of k minus 1 is equals to 2 to the power of k minus 1. The third step is proof true for n is equals to k plus 1. Here we're going to add a term on the left side of the equation where n is equals to k plus 1, which is 2 to the power of k plus 1 minus 1. While on the right side of the equation, we're just going to substitute the value of n, or the exponent n, with k plus 1. By that, we can already solve the equation. To do that, we're going to substitute 1 plus 2 plus 2 squared plus plus 2 to the power of k minus 1 with 2 to the power of k minus 1. But where did we get 2 to the power of k minus 1? Let's take a look at the second step. As you can see, we got 2 to the power of k minus 1 here in the second step. Going back, after substituting the value of 1 plus 2 plus 2 squared plus plus 2 to the power of k minus 1 with 2 to the power of k minus 1, we're going to bring down the term that we added before in the equation, which is 2 to the power of k plus 1 minus 1. Moving forward, let's take a look at line number 4. Here we got 2 times 2 to the power of k minus 1 equals 2 to the power of k plus 1 minus 1. How did we get 2 times 2 to the power of k? There is a rule in that. It says that whenever we add terms with the same exponent, we're just going to multiply the base. And that's where we've got 2 times 2 to the power of k. Now, multiplying 2 times 2 to the power of k, we've got 2 to the power of k plus 1. But how did we do it? There's also a rule that says that whenever we multiply terms with the same base, we're just going to add the exponent, and that's where we got k plus 1. Finally, we've got 2 to the power of k plus 1 minus 1 is equals to 2 to the power of k plus 1 minus 1. It shows that both sides are already equal. And that's where we end our step number 3. Since we already proved that the given problem is true, therefore, by the process of mathematical induction assumption, 1 plus 2 plus 2 squared plus dot 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 plus 2 to the power of n minus 1 is proven to be equal with 2 to the power of n minus 1. And that ends our discussion. Thank you.